Welcome everyone. In this video, we're going to learn about transformations of exponential functions. We already learned about transformations in cubic functions, quadratic functions, and the possible transformations were reflection, dilation, and translation. The same transformations are possible for the exponential functions as well. So let's deal with the reflection first. In reflection, there's a reflection about the y-axis as well as the reflection about the x-axis for the exponential functions. So we're going to learn reflection about the y-axis first. So the function y equals b to the power x. So this is a parent function, and we're going to reflect or transform that to y equals b to the power minus x. Okay, let's take a very simple function, y equals 2 to the power x. That's a parent function we're going to take, and we're going to transform that to y equals 2 to the power minus x. Okay, so this is how the y equals 2 to the power x looks like. You can see that the y-intercept x equals 0 gives y equals 2 to the power 0, which is 1. So 0, 1 is one of the critical point on the graph y equals 2 to the power x. So on the graph of this one, y equals 2 to the power minus x, where does the y-intercept occurs? So when x equals 0, when you substitute x equals 0 into this equation, you get y equals 1. So that means y-intercept is on the same point itself as on the y equals 2 to the power x. Okay, let's now see what happens when x equals 1 here. So x equals 1 here gives y equals 2. So it's a 1, 2 is one of the point on y equals 2 to the power x. So now we're going to see the corresponding point for this graph. Okay, so to get y equals 2 here for this function, we need to put x equals minus 1. So x equals minus 1 gives us y equals 2 to the power minus of minus 1, which is plus 1, so it's a 2. So that means the other point on this graph, which is mapped on the other graph, is minus 1, 2. So this graph looks like a graph which is reflected about the y-axis. So this gives the reflection about the y-axis. So for both these functions, you can see that the horizontal asymptote is the same, and that's x-axis. And so the range of these two functions is 0 to infinity, with 0 is not included because these values, the range, the y value never reaches 0 because that's the asymptote, and it goes up to positive, any positive real values. Now let's see how the function is reflected about the x-axis. So now we're going to see the function y equals b to the power x, which is the parent function, and that's getting transformed to y equals minus b to the power x. Okay, so that's the function we go to. Let's see how this function looks like. Okay, now let's take a simple example, y equals 2 to the power x, same previous example. And now we're going to see how the graph y equals minus 2 to the power x looks like. Okay, as I said, this reflects the graph about the x-axis. Let's take some key points. Maybe x equals 0, that's a y, that gives us the y-intercept. Okay, x equals 0 gives for y equals 2 to the power x, y equals 1. So 0, 1 is 1 point. And on this one, when x equals 0, this function goes to y equals minus 1. So the function has a y-intercept 0, minus 1. Okay, so the graph is going through y-intercept 0, minus 1. And maybe if you want, you can take one more point, x equals 1. What happens? Y equals 2 for the parent function, and for this function, the transform function, x equals 1 gives y equals minus 2 to the power 1, or which is minus 2. So one thing which you should be very careful in here is this is not minus 2 to the power x. This is simply a coefficient minus in front of the function 2 to the power x. Okay, so this is not equals to minus 2 to the power x. So how does this function looks like then? So this function is a function which is reflected about the x-axis. Okay, so y equals minus 2 to the power x, which is the blue one shown in there. And how about the horizontal asymptote? The horizontal asymptote, you can see that the both graphs are approaching to the 0, the y equals 0 or the x-axis. So both have the horizontal asymptote same, but the range is slightly different. For the parent function, so for this function, the range is 0 to infinity because it goes in the positive y-axis, and but whereas this one goes in the negative x-axis, negative y-axis. So the range is minus infinity to 0. In both of these, 0 is not included. That's why we put this parenthesis, which shows the 0 is not included because that's a horizontal asymptote. Okay, I hope that makes sense to you. And let's now move to the next transformation. Okay, now let's deal with horizontal translation. The function y equals b to the power x is transformed to y equals b to the power x minus h. So this is exactly like the other horizontal translation which you have seen in quadratic functions and cubic functions. If there is a minus h in here, so which means the function is translated to the right along the positive x-axis by h unit. Now let's take the same parent function y equals 2 to the power x, and that's getting translated to y equals 2 to the power x minus 2. Okay, so you can see that by comparing these two equations, it's h equals 2, so which means the graph is the y equals 2 to the power x is simply translated to the right by 2 units. Okay, so the graph will be looking like that. So now, as you can see in there, the y-intercept is changed. When x equals 0, the y-intercept for this function, the parent function, was 0, 1, whereas in here, when x equals 0, you get y equals 2 to the power minus 2, which is 1 on 2 to the power 2, or that's 0.25. So that means the y-intercept of this function is 0.25, y equals 0.25. And that's why this graph is cutting the y-axis at 0.25. And how about the range and the horizontal asymptote of this function? Horizontal asymptote, as you can see, it doesn't change. The horizontal asymptote is still the same. It's the x-axis, and the range is also the same. It covers all the positive values from 0. So the range is 0 to infinity, as with the parent function for this function as well, y equals b to the power x minus h. So one last thing is the vertical translation, where the function y equals b to the power x is translated to y equals b to the power x plus k. Okay, as with any vertical translation, this also signifies, the k signifies how much we are translating the graph up or down. If k is positive, that means the graph is translated to in the positive y-axis by k unit, and if k is negative, it says the graph is pushed down by k unit. Let's do an example. Y equals 2 to the power x, which is the parent function, which is getting translated to the function y equals 2 to the power x minus 1. You can see that k is minus 1. So this simply means the whole graph is pushed down by minus 1 unit. Okay, so this is how the new function looks like, and you can see that in that one, the horizontal asymptote, y-intercept, all these things have changed. So we need to find carefully what the y-intercept for this function is, and also the range and the horizontal asymptote. Let's figure out what is a y-intercept for this function. You can see that when x equals 0 for this function, the y-intercept is 0, 1. But when x equals 0, that's when the y-intercept occurs. X equals 0, this function, this value 2 to the power x is 1, and that's 1 minus 1, which is 0. So that means for this particular function, the y-intercept is 0, 0. So that's why it's going through cutting the y-axis at the origin. So what is the horizontal asymptote? For this function, when x tends to minus infinity, that's how you find the horizontal asymptote. When x tends to minus infinity, the function y is going to be 0. So it's tending to 0. It never reaches that value 0, but it's approaching 0. So that's why we're saying, okay, for this function, the horizontal asymptote is y equals 0. But in this one, when x equals minus infinity, so x tends to minus infinity, we get y equals 2 to the power minus infinity. That's approaching 0. This and the first term is approaching 0 and 0 minus 1. So that means y is approaching the value minus 1. So the horizontal asymptote for this function is minus 1. So the range is also determined by the horizontal asymptote. So you can see that the blue function y equals 2 to the x minus 1, the y can take any values from minus 1 onwards in the positive direction. So the range of that function is minus 1 to infinity. Okay, so any value from minus 1 upwards. And again, minus 1 is not included because it's the horizontal asymptote. Okay, there's one more transformation for this function, which is dilation. So in dilation, you can see that I have shown in here two functions, y equals 2 to the power x and y equals 3 times 2 to the power x. So the function is going from y equals b to the power x to y equals a times b to the power x. Okay, so this is not a times b the whole power x, that's not correct. So this is simply a coefficient a in front of b to the power x. And you can see that the blue one, which is having a as 3, so which is dilated from the x-axis by 3 units. So this is increasing more quickly compared to the other function, the parent function y equals 2 to the power x. As you can see there, the y-intercept is different for these two functions. So for this function the function y equals 2 to the power x, we know the y-intercept is 0, 1. And for this function y equals 3 times 2 to the power x, when x equals 0, this function has a value for y as 3. So the y-intercept for this function is 0, 3. So the y-intercept, you can see that it's 3 times higher compared to this function. So this is when the dilation is occurring for the function about the x-axis. So now we covered the different kinds of simple transformations that can occur to the exponential functions, which are a reflection about the y-axis and x-axis, horizontal translation and vertical translation, and the dilation about the x-axis. And in the next video and in the next lesson, we will learn how we can combine multiple transformations on a single function.